think we need some better networking technology here, or something that's a little more robust to failure.
Yeah, you'd think this
Um,
wouldn't be so hard.
yeah. um, cool. I think we were chatting about uh, the sort of question of optimization questions that come up in terms of like placement. And I mentioned like a load balance example and a firewall example as two sort of cases of it's not entirely clear where things are supposed to go. Um,
And yeah, where I sort of answered, my response was they go in the network. And that those two examples that were interesting because one could argue that it's the controller of the virtual network that implements the firewall. Take that example by installing all of the right rules into the flow tables. So that is, I think, an interesting dimension of the problem, which is um, just going back and sort of restating some things. A service runs in a resource container that consists of a set of virtual machines where the code runs. It scales up, and you have to worry about where those machines are placed at the edge or in the data center, connected by a set of networks. And again, there are certainly going to be private networks, but there will private virtual networks. There will be public-facing virtual networks, but there will also be private virtual networks that are shared with other services because you need to compose with them. But each of those virtual networks is itself, ideally, a controlled programmable network completely in the sense of SDN. So there could be a controller. So that's yet another place that some code is running. So how, and that then leads to the interesting questions of what belongs in the virtual machines and what belongs with the controller of the virtual networks those virtual machines connect to. Yeah, it's a quite interesting space to be thinking about.
So I guess like I mean we touched a little bit on optimization in terms of like balancing load. Another sort of thing seems to come up: isolation and access control. Do you think there are some other sort of like big questions that we need to be thinking about? Like aside from just the isolation questions, um, you know, um, resource isolation, load balance,
Yeah.
and then
Well,
provisioning. There are
but
some other big.
one of my favorite catchwords right now is operationalization. Um, and this is again what the cloud brings us. It's a problem we have to deal with. We are so used to thinking about, well, I've got the software and now I'm done. I install it and I run it. But of course, running software in the cloud is an entirely different operation. It runs 24/7 and it scales, and it's not just a passive thing. It's an active thing that is always running. And um, there's a lot of things that go into operationalizing the service, even if that service was built to be scalable. Let's say the software is scalable. Once I deploy it, I have to monitor it and understand when it's necessary to resize it or scale it up or down. There is generally some kind of load balancing / request routing that goes on with that. That its performance is not going to scale if I don't keep the load spread out on it. So load balancer, a minute ago we were talking about it. It could in fact be a function that runs in a controller on top of a virtual network. Load balance might also be a standalone service because it's now directing requests not only to the right server in a load balancing way, but to the right site where that server might be, because again, these virtual machines are potentially everywhere. So I actually think I'd call it request routing. You could call it load balancing, but I think that's one of those foundational services that other services are going to depend on, and I think there's a modest set of them that collectively help you operationalize your service so that you don't have to start from scratch. I think that's the interesting challenge, which is, can we build out that core set in a way that makes the next service that comes along easier to operationalize? That's kind of the idea behind open platform as a service. We'll give you some tools, and you just give us your new bit of code, and we will auto-scale it and all of those things. But I think that those can go even further if we really believe that everything is in fact a service. That becomes your fundamental building block.
When you talk about optimization as well, another question I've had when thinking about these problems is like, what's the cost of placing a virtual machine? I mean, it seems like in some limited discussions I've had about this, people are like, yeah, it's pretty much free. Like we can place virtual machines like anywhere in our network. Is that really the case? Like when we think about like placing a function in the network, is it really free in some sense? Like, oh, it's just as easy as just spinning up a virtual machine, or is there more to think about there?
Well, we do a CDN demo where we click a button and virtual machine spin up, but I think
Right.
there actually is a cost to it. I think we're going to have to maybe refactor some things. It could very well be the case that virtual machines are, if they're virtually free to have one, then it becomes a question of merely assigning resources to it. And that was kind of a model that we had from Planet Lab that I still like, but it's actually a fair bit different than the way a lot of cloud systems are built today. And I'm most familiar with OpenStack, where you spin up a KVM virtual machine and you've said how many resources it has, and that's how many it has. And you don't suddenly change that without tearing it down and standing up another one. In my view, virtual machines should be, and their existence should be decoupled from the resources that are assigned to them. But that's a refactoring that will have to happen. If that were the case, then I think you probably, it's not so costly to have potential virtual machines just waiting for you to do resource assignment to them.
Right, and then it's just a question of like how many resources do you allocate to that particular virtual?
Yeah. It becomes it entirely then becomes a resource allocation problem, which ought to be something that can be done at a very pretty low overhead.
You mentioned a couple things there, like in the answer to that I wanted to just briefly kind of like touch on. You mentioned sort of your work with Planet Lab and also OpenStack. So I had a couple questions there. One is sort of like, what's the relation? I mean, how did you come to working on this from Planet Lab? And then the other is like, what's the relationship of OpenStack to NFV, and also like in particular what you're working on now with OpenCloud? Maybe what is OpenCloud?
Yeah. All right. So yeah, I could going back into the past a long ways. I've always, going way back to when I was thinking about working on the X kernel, it was always sort of the intersection of communication and computation. It's always found to be an interesting problem. And X kernel-like work, we did a system called Scout, kind of took us in the direction that eventually meshed with active networks, and that was still about the same thing. But the disconnect between that work and Planet Lab a little bit was very much influenced by I believe it was a CTSB report, a written National Research Council report written back towards the beginning of Planet Lab. I'd have to go dig up the exact citation, but it was drawing on the inventor's dilemma and disruptive technology. And when applied to the internet, which at that time we started running around saying the internet's ossifying, the answer was overlays. And so that was sort of that is the right bit of leverage. Let's just build overlays. And that kind of is where Planet Lab started, and we looked around at the time, and vServers were the best choice, which is a container-based virtualization, is the best choice for that. And we had to write a lot of our own stuff because it didn't exist at the time. Today, you can go get these things practically anywhere, and so OpenStack is one source of software. It tends towards heavier weight virtualization like KVM, but Linux containers is today's version of vServers, which we started with. So we've been pursuing, or trying to turn Linux containers into a first-class virtualization technology, but a container-based virtualization technology rather than other types. And in answer to the earlier question about how cheap is it to start up a virtual machine, if it's a container-based virtual machine, it's a very inexpensive thing, and the overhead for having it and keeping it around is very low. So I think containers are a really important part of the ecosystem. But in any case, what we started to do was think about re-engineering Planet Lab using modern-day technology and software, open source software like OpenStack. We started down that path, and almost concurrent with that, in parallel, that was kind of what we were doing on my researchy side. And at the same time as when that story I was telling earlier about Coblitz becoming a product that we were selling to telcos, and they were starting to put it into the middle of their networks. And so we've got this Planet Lab experience about widely distributed virtual machines meets today's technology for that, which is OpenStack, influenced by requirements that operators have, which are different than requirements that data center operators have, that data center providers have. And that all kind of started to come together and ultimately was sort of the genesis of Open Cloud, which, you know, is by one definition a follow-on to PlanLab, but I think that's way underselling it. Yes, there are virtual machines, and yes, they are lumped together in things called slices, but beyond that, we start with Open Cloud starts with OpenStack as the underlying virtualization cluster virtual machine management layer. It also comes with identity management, a subsystem called Keystone. And Neutron is the network as a service layer of OpenStack. But what we've done, or are in the process of doing, is sliding in a new network hypervisor called OpenVertex. It comes out of the Open Networking Lab. So, and it's an OpenFlow-based hypervisor. It creates virtual networks, but you can assign a controller. It gives you control isolation. You can assign your own controller, your own network OS to your virtual networks. That then is the cornerstone of the infrastructure as a service aspects of Open Cloud. But we've then looked around and said, well, these services are what it's all about. So it makes a service a first-class object, and as you're allowed to add services and extend the Open Cloud operating system with new services, and there we're very much inspired by Unix, right? As a Unix user, you start to forget where the line is between what was in the kernel and what was user commands and libraries, and what's in /bin. Then it really doesn't matter. And so we start with OpenStack. We add in a new network hypervisor technology, and we have deployments that are going all the way from the data center to the wide area network to the edge of the network. OpenFlow switches being controlled by the hypervisor. OpenStack clusters at each one of those, in the network, at the edge of the network, in the data center. And then you're left with the orchestration problem, which is what Open Cloud's about.
Mm-hmm. It sounds like it sounds like a great environment to do some of the research, like to start working on some of the research problems you talked about. I mean, is it? I guess one question I have there is, like, it sounds great. Like, can we use it? Like, is it ready? And, like, I guess what would be the first thing you'd work on? Like, if it's rearing and ready to go, because it seems like a great thing for people to jump in on.
Well, like I was calling that the virtual machine placement problem because I think that's an extremely interesting one. Mm-hmm. But I don't think you can view that in isolation without also considering the topology of the virtual networks you use to compose them. Mm-hmm. And then that gets you into composition, gets you into the composition problem. And then once you have composition, that causes the VM placement to change. So they're all kind of interrelated. So I think that's a very interesting space. And the second thing, which is sort of what we're already trying to do, is back to operationalization, trying to understand what it really means to take a piece of open source software that's supposed to be scalable. So Cassandra is our canonical example. It's a NoSQL database. And try to stand it up using the Open Cloud abstractions as a multi-tenant, 24/7 scalable service. And what were the problems you had to deal with? And there's a secure bootstrapping problem that you come into. There is request routing or some kind of load balancing. There's health monitoring. Certainly provisioning is part of it, but we kind of had the provisioning aspect there. So trying to understand what those are and then break those down and build those as services as well. I think there's, not to mention all the new interesting services people are going to be thinking about.
So Open Cloud's kind of, it's described kind of as a research infrastructure testbed. I guess not to draw too many parallels with Planet Lab, but much like Planet Lab was sort of a way for researchers to do some real stuff in distributed systems. I'm wondering, like, do you see it that way? Do you see it as a place for researchers to test out certain kinds of things? Do you see it as Planet Lab also, by the way, had some pretty long-running services. Like, where do you see things going there? Do you think it's going to be a research playground, shall we say? Do you think it's going to be a host, for some specific long-running services?
I really, really hope it becomes a place for long-running services. And we're trying. I mean, in retrospect, one of the things Planet Lab didn't do, and I don't know that we could have at the time, was those interesting services that got up and running actually nurtured them and helped them along. And offer them, make it more easy for users to get to. We tried to be a little too neutral and said, well, Nick's created an interesting MumbleFrat service, you can go use his. But if we had allowed you to integrate that into Planet Lab and it appeared as though it were a first-class part of Planet Lab, then that would have been a good thing. That's not the only thing that would have needed to happen. You have to fund the ongoing operation of it, which is a whole other matter. But yeah, I think the way that we're thinking about it is it draws, if you go back and read the original Planet Lab white paper, you'll see something similar, except we didn't quite execute it in the way we're trying to execute it this time, which is we're trying to build an ecosystem. I'm sorry, we want OpenCloud to be part of the cloud ecosystem. And what that means is it's certainly a place that researchers come to, but it's also a place that industry comes to. And one of the things, of course, you'd like to see technology move from research into industry, and there were a few examples of that in Planet Lab. You would like to see open source software that's important to industry fold back into OpenCloud, and we're doing that. OpenStack is the starting point that's critically tied to its traction in industry. And I think it's not just a showcase for research, but a showcase for any innovation. I mean, not just a showcase for the academic community, but a showcase for those third-party service vendors that we're hoping to start to prop up. And you know, we're partnered with Internet 2 in a very interesting way. They're not just, well, we're using Internet 2 resources. We have clusters in Internet 2 routing centers, and I think there's interest within the Internet 2 community to make this a showcase for, Internet 2 is supposed to be about next generation Internet. Well, the next generation Internet isn't just about gigabits and terabits. It's also about functionality. And so a showcase for this kind of functionality, whether you call it NFV or you call it a cloud app or it's the blurred line between them, I think that's a real opportunity. Yeah, so the answer was all of the above.
Yeah, that seems interesting. I guess one theme that seems to be coming up a lot, like as I sort of do this course for the second time this year, one of the biggest things that comes up as a theme, like whether we're talking about things like NFV or things like Open Daylight or other things in this space, is that it's certainly becoming clear that like when people talk about SDN, it's certainly more than just OpenFlow, but it's also maybe more than just N, right? In the sense that like it's more than just programming switches. So I guess maybe like to a good place to wrap things up might be to talk about like where do you see this whole how do you see this whole area kind of like shaping SDN? Because it seems like SDN, as we knew it several years ago, is much broader than what it once.
Well, it depends on your definition, of course. I view SDN as a key enabler here. I don't think it was. Right. I think it's a means, not an end. That's my own opinion. Mm-hmm. I think it's really about delivering services and functionality.
But I guess, like, to the point of like maybe I'll make the question a little more problem focused. Like when we think about solving network management problems or service, problems involving services and networks, like, certainly as a networking person, I've always sort of thought about like using a controller to configure routers and switches and things like that. But it seems to me like it's going to be harder and harder to think about problems without thinking about the network and the hosts.
That's right. And you sort of, I'm sensitive to this, which is talking about the individual devices. So here would be my wrap-up point. I think we have to get to a place that we think about programming a little differently. And Computer Science 101, we're taught the distinction between the interface and the implementation. In this space, the interface is network-wide. You cannot think about the interface to an individual. That's a subroutine call. You can't think about the interface to the individual devices or the individual virtual machine instances. You're thinking about the interface to the network-wide function. And in SDN land, we call that an SDN controller. I would slightly generalize that and call that a service controller, which SDN is a specific example. It is the interface to a network-wide service. The implementation of that service is a set of instances, whether they're virtual machines or physical routers, and yes, there will be a southbound interface from the service controller to the individual things, and certainly the more you can coalesce those, the better. But that's an implementation problem. Then you get into optimization and placement and so on. The the struggle we're having, I think, getting over the hump there is we're so eager to optimize that we haven't quite got our heads around the abstraction yet. And I think once we do that, then there's tons of room for optimization. But those are optimizations, and as Brian Greenhan always tells us, get it correct first, and then worry about optimization.
Right. Yeah. No. It seems. It definitely seems like we're still in the world of like plugins.
We're still writing assembly language.
Right. Like here's the plugin to control the network switches, and here's the plugin to sort of spin up VMs, but there's no kind of as you put it, like a network-wide abstraction for services, and that's what we should be doing.
Yeah. I mean, this is way oversimplistic, but we understand modular programming as a way to control complexity. I'm just claiming that the service, as I just described it with the service controller as the interface, is the module of the cloud. And I think that when you start there, it helps to separate the concerns in the right way.
Cool. Yeah, there's a ton of food for thought there. Great. Thanks a lot for your time. I had a whole list of questions, and I think we just
we danced all over.
Took off the tip of the iceberg. I think in this area, it's just probably going to be a lot more to talk about, like in the future as well. So this is great. Thanks a lot.
Yep. You're welcome. Enjoyed it.